Imagine today that you are in a small startup. And in this small startup, you build mobile apps. And not just that, you have thousands of merchants, but millions of app users with these merchants on those stores. And these merchants, when they use these apps, they want to know what their usage performance is on these mobile apps, what the revenue is like, what's their sessions like. And so today, we're going to talk about this startup named Tapcart that's going to get to show how are they able to bring out this customer-facing analytics platform using with all of these merchants that they have to work. So just about a little bit about Tapcart. Tapcart, we are a app building commerce platform for Shopify merchants. We build basically mobile apps for all of our merchants that want to build the apps for their store. So examples, say you have a really lucrative t-shirt brand that wants to expand their store onto an app. So how do we do that? Well, first you could pour a lot of your resources in building an engineering team and build that app from the ground up. Or you could go to Tapcart and we could help build a mobile app for you guys with as little as a few weeks and launch that app to iOS and Android store. Just a really quick summary of Tapcart. We're currently 1,800 Shopify brands, and we help generate $6.2 billion in revenue since Tapcart started 7 years ago. We have millions and millions of app users, both on iOS and Android. And mainly we work with Shopify, we work with fashion apparels, but we also work with home goods and food brands. And we're also Series B, backed by Shopify investors as well. So just a show of hands, how many of you guys know any of these brands that you see here? I do see Fig, I see Culture Kings, Feature. These are just some of the few merchants that we work with. And yeah, we have a lot of merchants that rely on Tapcart to expand their store using a mobile app. We're not just like a product, we're a platform. We provide tooling to build your app using the App Studio, as you just saw. We also provide marketing to push out push notifications to those apps. And one thing I want to really focus on today is that we also provide an analytics dashboard for your store's performance on those apps. And today, we're going to talk about how Tapcart got to where it is then to where it is now. And yeah, so our analytics product is called Insights Pro, and it is a customer-facing analytics product. This is only for merchants to see. And so on this dashboard, you get to see over 30 metrics that are produced from the app. Metrics include what's your revenue, what's the customer lifetime value, number of sessions, who's returning, who's new. And this type of dashboard, you can set any time range, and so you could go back as far as 7, 30, 90 years of start and end time range. And this data is updated near real time. So when you go to the dashboard, you can see as time goes on, the dashboard updates without you needing to refresh. But why do we need to use real time? Why not just a batch? Why not just having a report that just tells you like the last day's performance? Well, near real time gives us more of a competitive advantage with our other players in this market. And for specific events like Black Friday, Cyber Monday, or when merchants send a marketing campaign, we want to have the merchants experience to see a reaction on when those events happen. So for example, that peak over there, after they send a push notification, they should be able to see some type of growth in their revenue, for example. So this slide just shows the number of metrics that we provide to our merchants. And this includes top searched, conversion numbers on your push performance, including new or returning users, segmentations, what kind of users are they? Are they VIP users? Are they brand new users? Or are they just users that just haven't been shopping with us for a while, but just came back? Conversion funnel, you name it. A lot of these metrics we support on this dashboard is something that we make available to our merchants. So how do we get here? How do we get to all those metrics, and how do we get to display it onto an analytics dashboard and make it all real time and make it all look like how it is there? So we're going to talk about, kind of do a little exercise on, what is the requirement to get to that product, and so what should Insights Pro support technically? Well, it should support millions of mobile events a day. We get, again, we have millions and millions of devices around the world sending mobile events to us, and we need to be able to surface that data up to the dashboard. Metrics over time, any time, so not just yesterday's or the last 24 hours. We want to be able to surface last 7 days, last 30, last 90, and we wanted to be able to go on the entire history of when they started their app with Tapcart. So why would you want to go so far back? Well, merchants want to see not just month over month, but year over year comparison, see how well they're doing throughout that time. We also want to be able to show hourly and daily grains of data. So if you were looking at the last 7 days of data, you will see 7 different data points aggregated for each of those days. And then in a daily grain, 24 hours, if you're looking at just one day, you'll see 24 points of data aggregated for those hours. And the reason why we want those specific grains is so that when merchants send a push notification, we also want us to be able to see what's the reaction on the next hour or the hour after that. One thing we also really want is that have these charts be a fast response. So a good experience with these dashboards require a fast response. And sub-second is something that we aim to achieve. Anything higher than that, 5-10 seconds, is not an acceptable experience for our merchants. So we want to have a fast response time. We want to be able to adjust 25 different types of mobile events. So we have different mobile events, including product viewed, add to cart, purchase complete, wish list added, account created, signed in, etc. We want to be able to handle all those events. And different dimensions, including different OS, iOS, Android, if they're returning or new users, source, if they came to the mobile app organically, or they clicked on a push notification, or they came from a campaign. We want to be able to slice and dice those dimensions. And lastly, this is very important when we want to handle thousands of requests at any given moment. So why we want this so bad is because during Black Friday, Cyber Monday, when everyone's on their phone trying to get the best deals out of their, out of the event, merchants want to be able to see how well they're doing at the time that drop happens. Or when they send a push notification, they have multiple of analysts accessing the dashboard, and we want to be able to handle that. So building Insights Pro. So what were the approaches, or what were the options that we had building this? So naive approach, we said, okay, maybe let's try a relational database. Thinking maybe a MySQL or Postgres database that's really simple to use, just take SQL queries. But straight to the con, it requires a large instance because remember we talk about we have millions and millions of data coming in, and we could have as much as 7 years, 10, 20. We're going to need to scale up, and it's not a way to go when we want to do store that much data. It's slow to aggregation. This is something we're going to be doing a lot with our metrics, so we want to aggregate a lot, and we can't have slow aggregations. And it's definitely not built for OLAP, online analytics process. We didn't go for a relational database. So for the second option was maybe a data warehouse. Data warehouse, we are a GCP shop, Google shop, so we had BigQuery as an option for data warehouse. And we wanted to use BigQuery because it was such an easy way to ingest the data, and it was easy to use using SQL. And you could query using columnar, so you can only get the data back as much as what you are selecting. And it's scalable in petabyte scale, as they advertise. And it is definitely an OLAP database. However, slow aggregations. We know that when we queried data warehouses, they're not meant to be really fast. They're just meant for reporting. And we want to have really fast response. And it gets really expensive to query this database, especially when you're always returning, scanning large amounts of data. It could get really expensive to query data warehouses. And data warehouses, they don't support high concurrency. There's a lot of, imagine going to a meeting and all 50 of you or 100 of you are looking at the same reporting graph, and you could probably imagine that reporting graph will take 30 seconds to an hour, or 30 seconds to a minute, excuse me, and that's just way too fast. And we don't want that because merchants will have a lot of users, and if they're all hitting the data warehouse, it's going to be way too, it won't be able to handle that many query over time. So the way that we actually went forward was a streaming process in which we pre-aggregated our metrics using Apache Beam. And we store that data into Bigtable. And so generally it's a materialized view. And how that works is, to put it shortly, we actually create our metrics using Apache Beam and just write that to Bigtable. On Google, we use Dataflow, which is the managed service for Apache Beam, and Bigtable, HBase database that Google allows us to use. And yeah, it's really flexible to use. Creating these different transformations on the Beam pipelines allows us to reuse those transformations across different metrics. And we can use either Python or Java, and it's scalable, it's managed. We could set the nodes auto scale. But there's a lot of cons to that too, and I'll get there to a second. But first, I want to show you, I guess, really simply how our pipeline is set up. It's rather simple. So on the far left, you can see the app just being a data producer, sending their data in batch to our Cloud Run service, which is a Google managed service that stands up Kubernetes pods for us. And essentially, it's a microservice, and that service directly writes that and persists that into PubSub. And then from there, PubSub either go to two ways. One, to BigQuery for just more persistence and just internal reporting. And then the other route is to Dataflow. And we stream that into Dataflow. And what Dataflow does is it does the pre-aggregation as it comes in, windows certain data, bounds them, and then aggregates them and writes to Bigtable. And so in Bigtable, how we decided to set this up is we put all these metrics into the row key, where the row is the app, the grain, and the time, and the value is where all the metrics live. We have different columns, and so each column is essentially a type of metric. So we have 30 metrics, 30 columns. And the way that we store all of this is that the way that we retrieve that is that when Insights Pro decides to query that data, say we have a start time of January 25th to February 23rd, we create a key of a start and an end, and it queries Bigtable and pulls that and brings that to our client through our microservice. Why we chose Bigtable is because Bigtable is really good as a time series table as well. And why that is because they store their rows key in lexicographical order. So if you give it a start and end, it will return everything in between, including the bounds. And so we were able to, that's how we were able to get the start and end time and bring that all the way up to the dashboard. So back to the chart that we were talking about, there was a lot of issues using this approach. One was that we had a large aggregation time window that was really difficult to manage. We had a lot of states to set up when we have to aggregate over a day, 7 days, a month. It was not scalable at all, especially when you have a lot more merchants joining Tapcart. Adding new metrics is very difficult too. All of our metrics are literally basically defined as transforms in Apache Beam, and that could get really hairy and dicey. And so even when we create a new metric, we had to backfill. We had to pull data from the raw events stored in BigQuery and do the backfill there. It's not very streamlined when we decide to add a new metric. Also, when we do the aggregation, when we pull the data from Bigtable, we also have to put our logic on in the backend side of the entire pipeline. So when I mean the backend, that's the microservice that's pulling data from Bigtable. And that's not a good practice to have when you have different logics everywhere and not in one place. And so that makes debugging very difficult. And one other thing is time zones is a difficult thing that we have to consider, where say you have a merchant living in Sydney or in New York or London. Those aggregation bounds for a single day is different when you have different users across the world looking at the same analytics. And so we had to create a different time zone aggregation metric for each of those time zones. So if there's 24 time zones, we created every aggregation for every those time zones. It gets really, really difficult to manage. So with all of that, we were like, we got to fold on using Bigtable and think about what is the better solution, what is the better technology to use out there. And so we thought to ourselves, what if there was a way to get the simplicity of the data warehouse, but the performance of the streaming processing? So data warehouse. We like data warehouse because you can just store a bunch of data, throw a bunch of data in it. It stores there, and you can use SQL on it. But we also like the streaming process where it's able to ingest data really well, but also pull the data out really fast and query it as with high performance. And so with that, you probably guess what's the technology we use. We use Druid. And Druid, we decided that it was pretty much the best choice is because it's low latency for OLAP queries. It's really, really impressive. It's built for time series data, so you could that's basically what our analytics dashboard is used for, and we just only query by time series. You could slice and dice over many dimensions. So since it's based in SQL, you could do a lot of different where statements and filter them however you need. And streaming ingestions, this is also really important. It's able to just take in data, and then as soon as the data lands, you could query. And we also think that it's really easy to maintain, far better than using Bigtable. All of our metrics are now defined in SQL rather than creating a bunch of different transforms and having that define our metrics. It supports nested data, which we love, so we don't have to worry about flattening all of those nested data. And high concurrency, that's also super important. Scalable in storage and compute, so it is horizontally scalable, so we love that. And fully managed service, it could be supplied by imply. So being a small, nimble team, we can't handle Druid on our own. And so knowing that there was a company out there implied that provides a managed service of Druid, we were heads over heels using this. So that's when we got ourselves into using Polaris, which is a fully managed Druid database as a service. And what we love about it is that we don't have to worry about cluster management or even security. Using Zookeeper to handle manage all the different nodes. It's really seamless. We know that Polaris, they have a team, whole team dedicated to managing scaling, and a dedicated solutions technical engineer that could help us debug whatever issues that we have. It's like having a team out there just to further Tapcart's to give value to our merchants. And so when we add this into our pipeline, it's pretty simple. It was almost a plug and play. The only difference that we had to really change was data flow, the second to the right. And instead of creating all these transformation, we could just simply flow all that data as raw into Polaris. The reason why we don't, if this was a AWS shop, we could just use Kinesis and write straight to Polaris, but we had to use data flow, and we're just using HTTP to send our data into Polaris. And when we query that data, the data comes back, and we know what kind of, instead of just querying with using big table queries, we have a query that we know what it means and how it's defined. And for example, this query is just simply give me the count of sessions that was created when you opened the app through a push notification. So all of these SQL metrics is super easy to define and manage and maintain. And so learning and improvements, one thing that we learned throughout was when we decided to write to Polaris, we have millions and millions of events, and we don't want to rain down millions and millions of API requests to Polaris. Though if we were on Kinesis, if we were on AWS and use Kinesis, that could be able to handle all those requests for us. But since we're using HTTP, we decided to batch our HTTP requests and send those events to Polaris. So I'd be careful to saying it's real time. I call it near real time. Clustering columns, we discovered that obviously when we cluster our tables, our queries run more efficiently. So when we query by app ID or by some dimensions, we get a much better performance than not clustering. Segment compaction with bad data. We've seen sometimes bad data come in. For example, we see some really, really wild dates that come in because they change their time on their phone and they're able to send data with dates with 2027. But yeah, we're able to handle a lot of those bad data. Future improvements, we're thinking about using aggregated tables, using the roll-up features, truncating your timestamps, data tiering, and using schemaless jobs. And just one more thing with this slide, just wanted to say that when Tapcart used Polaris, we thought how easy it was for any startup at this size to be able to use this type of high performance, high powered database. And so, yeah, we would like to also thank Imply and the Polaris team for providing this database. And with that, thank you guys.